Welcome to EMI401 Superlab. In this lab, we're going to be going over the EMI401 skill sheet, which is about selecting simple hypothesis, prediction, or conclusion that is supported by a data presentation or model. For today, you want to make sure you have a skill sheet ready that says EMI401 at the top. You also want to make sure that you have a writing implement that you can feel free to follow along with us. Let's take a look at the background information here. So this is telling us a little bit about what the skill is. Science passages on the ACT often presented with an experiment and with data. Do not discuss the results. The test writers leave the analysis and conclusion part of the scientific method up to you. EMI 401 questions will ask you to draw conclusions or predictions based on the data from the experiment. These are usually the last questions in an individual passage, which means that you have already had the chance to analyze data in previous questions. These are typically questions 4, 5, or 6, 7 of the passage that you'll see. They almost always come at the end of the passage. So let's take a look at a sample passage. What you want to have right now is a pen, pencil, highlighter, some sort of marking device in your hand. So as we read through this, you can circle, highlight, or underline any words that are confusing. Marble, which can be used to make buildings, is composed mostly of calcium carbonate. Marble is corroded, broken down, by air pollutants such as fly ash, nitric acid, and sulfuric acid. Fly ash contains corrosive materials. Nitric acid, produced when nitrogen dioxide reacts with water, reacts with calcium carbonate to form calcium nitrate. Sulfuric acid, produced when sulfur dioxide reacts with air and water, reacts with calcium carbonate to form calcium sulfate. Experiment 1. The scientists measured the initial mass of 4 samples of the same piece of marble. Each sample had a surface area of 24 square centimeters. The scientists placed each sample in a separate container and added an acid solution, which is acid and water, with an acid concentration of either 30 parts per million or 100 parts per million. After 24 hours, the scientists removed each sample, scraped off the calcium nitrate or calcium sulfate, and measured the final mass of the sample. The scientists then determined the mass of marble lost from each sample in kilograms. Experiment 2. The scientists obtained marble samples from buildings of different ages. The outer surface of each sample had a gray crust of calcium sulfate, calcium nitrate, and fly ash. The concentrations of calcium sulfate and calcium nitrate in the crust were determined as shown in the table. Alright, let's take a look at that. There's a lot of chemistry involved in this passage, so let's take a look at any words that we don't recognize. Any words that we don't know?
Calcium carbonate.
Calcium carbonate. Nice. Any other words we don't know or don't recognize you want to go through?
Corrosion.
Corroded. Oh, corrosive. Any other words that we don't know? All right. So if we just take a look at those few words, the first one is calcium carbonate. All right. Remember when we have words in a science passage, there's 3 different ways that we can analyze them. It's either defined for you in passage, you can use context clues or background knowledge, or last choice scenario, you can look it up. See, we can't have a dictionary, so we try to avoid that third one. So let's look at calcium carbonate. First off, is calcium carbonate defined for us in the passage? It sort of is, but you gotta use some context clues to figure it out. So it's more second category than that first category. What is calcium carbonate? All right, if you read that whole first sentence, it says marble, which can be used to make buildings, is composed mostly of calcium carbonate. So what is calcium carbonate? Yeah, it's marble, that rock, that heavy rock, made mostly of calcium carbonate. When you think of calcium carbonate, think of that really dense, solid rock, marble, that a lot of buildings are made out of. Marble is then corroded. All right, the word corroded is actually defined for us in the passage. It's broken down by air pollutants. Last but not least, fly ash contains corrosive materials. Now, corrosive is not defined for us, but we did learn the root earlier in this passage. What do you think a corrosive material does to other substances? Okay, so now it corrodes them. All right, we see in corrosive, the root here, corroded. All right, so a corrosive substance breaks down other substances. All right, this is fly ash. All right, let's continue on and take a look at our two tables. You see table 1, that was the experiment where they, actually let's take a step back. What did they do with the experiment? All right, this was the data they got from the other side. It's kind of a long-winded explanation. How would you summarize what they did in the experiment? You had to go.
They measured for the sample, and then we sampled the
Sulfuric. Yep.
nitric acid, and
Nice.
they measured the concentration and then, right?
Yep.
And then they counted the massive loss of marble.
Mass of marble lost. Nice. Yeah. What caused the marble to be lost? And nice. When you expose acid to marble, one of the things it does is it wears down. All right, especially being made mostly of calcium carbonate. All right, this is a substance that's very easily affected by strong acids. All right, so you see here that sulfuric acid and nitric acid were added to each marble sample. 4 samples, 1, 2, 3, 4, and each one was exposed to a different amount of each acid. All right, so essentially you put rocks in acid and see how much marble is lost. What about the second one? What did they do with the second one? It was a little bit of a different experiment. It was a little bit more real world than the first experiment.
And they got a piece of 4 buildings, different textures. Here.
Yeah, good. So,
Oh, yeah.
nice.
And then
All right, so we see they changed the building chunks. They came from different ages, but what did they measure about each chunk? Right, they changed the chunk of building, so either chunk 5, chunk 6, chunk 7, chunk 8, all the different buildings. They measured the what?
the amount of sulfuric and calcium nitrate and the rest.
Nice. So on each sample, they found out how much calcium sulfate and how much calcium nitrate was on the outside of each sample. What's the purpose of this? Why would they do experiment 2, especially after what they learned about experiment 1? What are they measuring about those marble samples? They went up to buildings and they took a chunk off the building, measured how much calcium sulfate, how much calcium nitrate. All right, why would they do this? You might ask, what was the aim of this experiment? Remember, with aim, it's really just a combination of the thing you changed and the thing you measured. So what are they trying to figure out in this experiment? All right, so if we're looking at table 2 then, what we're wondering is what is the aim of experiment 2? Why did the scientists do experiment 2?
To see if the age of the building affects the calcium, sulfate, and calcium.
Perfect, yeah. To see, does age of the building impact how much calcium sulfate and how much calcium nitrate is actually on the building? Because what would that tell us about the building? If there's either a lot of calcium nitrate or if there's a little calcium nitrate, the same thing with sulfate, what would that tell you about the marble that the building is made out of? Nice, yeah. So it's how much the building is eroded, so you can tell things like, is it structurally sound? Would it collapse? All right, the more of this junk you have on there, the more erosion has happened to that building. All right, you can even see this downtown. If you look at really old buildings, all like the intricate carvings are really, really worn down. Whereas on new buildings, they're sharp with detail because they haven't really been worn down by acid. All right, So let's then take a look at the example question. Which of the following statements is supported by the data shown in Table 1? All right, we need to then take a look at each statement and figure out, is that statement true based on the data that we are looking at? All right, now only one of these should be true. So the higher the acid concentration used, the more marble mass lost. Is that true? In this case, let's see, concentration was 30 here, and we lost 10. Concentration was 100 here, and we lost 56. So that's true. What about when the concentration was 30, we lost 4. When we upped it to 100, now we lost 4.3. So that went up as well. So we know A is true. The lower the acid concentration used, the more marble was lost. It's the opposite. The higher the acid concentration used, the less marble was lost. That's not true. And acid concentration does not impact the amount of marble lost. Well, that's not true either. All right, so the one that was true here. All right. Now that we have a little bit better understanding of how the experiment was run, we want to try questions 1, 2, and 3, which are guided questions, so they have things on the side. After you finish questions 1, 2, and 3, you want to press play on the video so that we can go through the answers together. And right now, you want to press pause and give yourself a little bit of time to work out questions 1, 2, and 3. All right, at this point, you're pressing play if you are ready to go through the answers. Now, if you've gone through questions 1, 2, and 3, you should be able to do the following. You should be able to kind of analyze this next topic. What we're going to do is just kind of review what happens in each of these reactions. All right, so kind of both of these ideas start with buildings. All right, and you learn that buildings are made mostly, or marble buildings are made mostly out of which molecule? What is the molecule that buildings are made out of? Nice. All right, so we have some calcium carbonate. All right, now in the first, kind of one of the first things that they're measuring, they're trying to figure out what happens to these buildings if they are exposed to different acids. So if they're exposed to nitric acid, all right, if calcium carbonate is exposed to nitric acid, what happens to calcium carbonate if it's exposed to nitric acid?
The mass of the marble is
Good, because what does the calcium carbonate turn into? It's no longer calcium carbonate, it's no longer marble, now it's what?
calcium.
Excellent. Calcium carbonate plus nitric acid actually turns the calcium carbonate into something called calcium nitrate. All right, marble, calcium carbonate, super strong, sturdy, make a giant skyscraper out of it. It lasts forever. Calcium nitrate, loose, flaky. It's the stuff you can like scratch off with your finger if you go over to a building. It starts to crumble, or like sidewalks do sometimes. It starts to crumble. Really weak. You don't want a building made out of this stuff. All right. Now, we have to take a look back at the passage a little bit. What makes this process worse? There's 2 ways that you can make more calcium nitrate on a building, which is a bad thing. What are the 2 major ways that you can make a building have more calcium nitrate? What's one way that you can?
What nitrogen dioxide?
Okay, let's talk about nitrogen dioxide for a second. How does nitrogen dioxide relate to this whole problem? How is nitrogen dioxide related to this whole problem?
Nitrogen dioxide, when it reacts with water, it makes nitric acid.
Excellent. If we take this substance called nitrogen dioxide and add it to water, that's how we actually get nitric acid. All right, this is an example of acid rain. All right, if you ever heard of acid rain before, that's this. Is when nitrogen dioxide in the air mixes with water, you get this stuff called nitric acid. All right, the nitric acid then breaks down the building. All right, it's also bad for plants and other stuff too. Where does the nitrogen dioxide come from? What if we take this back one step further? What would make nitrogen dioxide? You have to even go further back in the passage trees. What? Well, fly ash is another example of this. The passage talks about 3 different types of what?
When nitric acid reacts with calcium carbonate.
Good. So this, yeah. So when we have nitrogen dioxide and water, we get nitric acid. But the source of this nitrogen dioxide, what is it? Nitrogen dioxide is a, read back to this first one, marble, which we use to make buildings, is composed mostly of calcium carbonate. Marble is corroded by what? Air pollution. Nitrogen dioxide is an example of air pollution. It comes like flying out of factory walls. So we get this air pollution going in the atmosphere. There's water in the atmosphere. So then that nitrogen dioxide turns into a factory makes nitrogen dioxide. You mix nitrogen dioxide and water, and you get nitric acid. You mix nitric acid with a marble building, and you get an old broken down building. Now it's a lot of steps, but it's good to be able to do this because now you can start to analyze questions a little bit easier. Now there's a few things that you can kind of substitute out in this as well, because we didn't just talk about nitrogen dioxide. Which other words can we kind of substitute in here? So nitrogen dioxide isn't the only pollutant. What other pollutant were we looking at in this experiment? Okay, so instead of nitric acid, we could use sulfuric acid. And if we mix calcium carbonate instead with sulfuric acid, what do we make calcium sulfate? And how do we get sulfuric acid? Nice. So instead of nitrogen dioxide with water, if instead we took sulfur dioxide and added it to water, now we get sulfuric acid. And where does sulfuric acid come from? The same fact. That's true. They both do require air, so the gas to be around. So we actually could put that. All right. If you can follow this train, you can answer any question about this, because this is essentially the conclusion that they came up with. All right. That factories are bad because they make pollution. Because that pollution mixed with water, which makes acid. The acid mixes with buildings, breaks up. All right. Now thinking about that, let's take a look back at this question. According to Table 1, which type of acid caused the most marble mass to be lost? Sulfuric acid. How did you get sulfuric acid? Nice. All right. And we have to compare even amounts. All right. So when sulfur acid or sulfuric acid was at 30, we lost 10. When nitric acid was at 30, we only lost 4. All right. This one is bigger. We know sulfuric acid. Okay, let's fly to the second one. According to Table 2, which marble sample had the most calcium sulfate? 8. How'd you get 8?
I looked at the column calcium sulfate, and then I looked at the one that lost the most.
So then, if we take one step back to this thing again, there's 2 ways that we can destroy a building faster. All right? How could we make a building be destroyed faster? What is 2 different things that make it worse for a building? And you learn each by looking at the different tables. So like Table 1 tells you one bad thing you can do, and Table 2 tells you the other bad thing. Exposing into sulfuric acid. Little bits or a lot? A lot. A lot. So like the more, you can either increase the amount of acid. So if you increase these two, you will increase the amount of erosion. Or what else could you do? You could leave the concentrations the same, but what other thing would be bad for the building? And that's what you learned from table 2.
Leave it for a longer.
Nice. You could also increase the time, and it'll get worse. So you either leave it out there for a long time, or you expose it to a lot of acid. Or you do both, and then it really breaks down. So if we look then at question 3, according to table 2, which sample of marble would have more calcium nitrate on it? One exposed to the atmosphere for 10 years, or one exposed to the atmosphere for 30 years? 30 years. Longer it's been out there, worse it is. What you want to do right now is, now that you have all this background information, you'll be able to fly through the last few questions, 4 through 11. Once you are done with 4 through 11, you should press play and we'll go through the answers together. If you are pressing play at this point, that means that you are ready to go through 4 through 11. First off, question 4. Which sample from table 2 do you predict lost the most mass throughout its existence? What do you think? How do you think 8?
Because when I look at table 2, and I see the amount of
Yeah, so this one's tricky because 8 seems to have the most calcium sulfate. So wouldn't that be at the most mass? But I will tell you that 8 is the answer. Why is 8 the answer?
just on the distance stuff,
So I like the math. That's actually in this case that. I'm glad it's in this case that could throw you astray though. Calcium sulfate, is that a good thing or a bad thing? Calcium sulfate is a bad thing. If the more calcium sulfate there is, the more calcium carbonate, the stuff you want, you lost. Alright, because remember in the end, the calcium, well no, this diagram is really complicated. Alright, but in the end, this is the good stuff. We like this. This is what marble is, this is what strong buildings are made out of. This stuff is bad, and this stuff is bad. That's what erosion is. This is weak, crumbly stuff that doesn't build up a building. Alright, calcium carbonate is the good stuff. So if we take a look then, D actually has the most calcium sulfate and the most calcium nitrate on it. It has the most bad stuff. So that's why even though these numbers are higher here and here, this means it lost the most mass. Because this is junk. You don't want it. So it's kind of a tricky one. Right? In fact, most people who took the ACT at this time were these. Oh, but the math was the less. All right, you just have to know that calcium sulfate, calcium nitrate, those are bad. Okay. Which of the following generalizations is consistent with the experimental results of experiment 1? Sulfuric acid more rapidly decays marble than nitric acid. Nitric acid more rapidly decays marble than sulfuric acid, or they're both the same. How'd you get A? Nice. At 30 and 100, it lost 10.9 and 56.2 grams, and that's way more than the 30 and 100 for nitric acid, which was 4 and 4.3. Here. All right. Which of the following hypotheses about the effects of age on the amount of calcium sulfate on a building is correct? This is one of those weird ones where it's worded, they give you the first half of the sentence, and you have to add the second half of the sentence to make it true. So as the age of the building blanks, the amount of calcium, blah, 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 blanks. Okay, what do we think the answer is?
D increases the amount of calcium sulfate on the building increases.
Okay, so as age increases, which in this case means we have to move down the chart, if we look at sulfate and move down the chart as well, we see these numbers are increasing as well. Which we see, right? 7. If the results of experiment 2 are typical, one would predict that a building exposed to the elements for 100 years would have, and again, this is another like finish the sentence. So it's a little bit weird. They force you to start the sentence with a building exposed to the elements for 100 years would have, and which one of these would a 100-year-old building have? Okay.
More calcium nitrate on the exterior than a building exposed to elements for 50 years.
Nice. All right. It would have to have more calcium nitrate than the 50-year one. All right. A can't be true because it wouldn't have more than an older building. So that can't be true. And B can't be true because it wouldn't have, so this is a 100-year-old building, it wouldn't have less than a 50-year-old building. That's right. And they wouldn't have the same amount because we know age affects it, which leaves B as the right. All right, let's take a look at number 8. Predict which sample from 2 would have the greatest amount of fly ash on its exterior. Now, here's an exciting bit of information. We haven't really talked about fly ash at all yet. All right, where is fly ash? Or what is fly ash? Pollution. All right, where's all of our other pollution coming from? In our case a while ago, we learned that the pollution is coming from what? Factories. All right, and the longer the building was out, the more other pollution it had. So in this case, the same would hold true. The longer a building is out, the more fly ash it has. So 8 is exactly right. Number 9, which of the following would scientists suggest to decrease the amount of erosion that occurs on buildings? What do you think?
Decrease the amount of nitrogen dioxide by 60%.
No. All right, you kind of have to think of the chain of events here. Erosion is bad. Erosion in this case is like calcium nitrate or sulfate. What causes that to form? Even before, well, after that, well, we know the acid is what's going to cause that to form. And the acid is formed by the 2 oxides, and factories make the oxides. This is a long chain of events. So if you want this to go down, you need this to go down, which means you need this to go down, which means you need that to be gone. Which means A. Then, according to the information in the passage, a sample of marble from which of the following buildings would be expected to have the greatest concentration, the tricky part here, is calcium nitrate. All right, a 10-year-old building with low levels of nitrogen dioxide. A 10-year-old building with high levels of nitrogen dioxide. A 25-year-old building with low levels of nitrogen dioxide, or a 25-year-old building with high levels of nitrogen. What do we think is the answer?
C, a 25-year-old building in a city with high levels of nitrogen dioxide.
How come? Why D?
Because the more the building is exposed to nitrogen dioxide,
Nice. All right, not only is it older, but there's also grass. Well, that's not a good place to be. Last but not least, a comparison of the results from sample 1 and sample 3 supports the hypothesis that marble corrodes more quickly when exposed to which one of these answers? A. So it erodes more quickly when exposed to uric acid than nitric acid. How do you get that? There's this one. All right, and remember, this is mass of marble lost. So you can kind of think of these like negative numbers. The bigger the number is, the more we're lost.
yeah, so that the bird lost more than nitric acid, so A is good, and B is carbon.
Nice. Perfect. All right. At this point, if you feel like you got these, go and take it. I would recommend that you do one quick review of like kind of our sequence of events like this, or go through and make sure that you understand this whole crazy chart that we made. All right. And one last thing, if you've watched the video all the way in, the word regulation means laws that prevent pollution. All right. More regulations mean less pollution. All right. More regulations will prevent pollution. That will probably help you at some point. All right. Good luck.